Okay, Chapter 4. We did Chapter 4.1 and 4.2. Now, 4.1 is really using your calculator and understanding probability distributions, knowing that all probabilities lie between 0 and 1. And if I add up all my probabilities, they should equal 1. Therefore, I will not be doing problems from 4.1 because it's all with the calculator, and I cannot show the calculator on the screen. So instead, let us go over to 4.2. And now we're talking about our binomial distribution. So remember my binomial distribution. It'll give me n, where it's a fixed number of trials. It'll give me the p, which is the probability of success. The q, which is the probability of failure. And the x is the number of successes I'm looking for, right? Successes. Alright, so let's look at number 21. 55% of the U.S. households say they would feel secure if they had $50,000 in savings. Yes, I agree, I would feel so secure. You randomly select 8 households and ask them if they would feel secure if they had $50,000 in savings. Find the probability that the number would say they would feel secure is exactly 5, more than 5, and at most 5. So let me write down our information. How many people did we randomly survey? 8. So my n, the number of fixed trials, is going to be 8. The probability that they said they would feel secure if they had 50,000 is 55%, so that's 0.55. And just for fun, let's go ahead and write the q down. Q is 1 minus 0.55, which is equal to 0.45. And then it says x. So for part A, let me erase that x for a second. Okay. Where's I need my calculator too, don't I? 1 second. Pause for a second. Let me get my calculator. Oh, there he is. Okay. Part A. It says exactly 5. So x in this case is going to be exactly 5. So x is equal to 5. Remember in our calculator how we do this? We go second VARS and then up to that binom. Now the question is it PDF or CDF? Since I'm only looking at one x, it's PDF. And then you're going to input it as 8, 0.55, 5. And if you do that, you'll get the following. You would get approximately 0.7, let's say 78. Let's actually round it up. 0.78. Oh, that's a lie. I did the wrong one. 1 second. Let's do that again. I was about to say that's too high. 8, 0.55, 5. Alright, 0.256. Do you know what I did in my calculator to get the wrong answer? Yes, instead of doing PDF, I did CDF. So this is 0.25, let's say 257. Okay? So the probability that exactly 5 said they would feel secure is about 25%. Part D says more than 5. So in this case, x is going to be more than 5. And you got to say to yourself, what's more than 5? Well, it's 6, 7, all the way up to 8, right? So on your calculator, when you do this, you want to input the 5, because the 5 isn't being included here. Remember, when it's moving to the right, when it says more than or at least, you always want to do one less, but you want to make sure you write it out. It says more than 5. So what does more than 5 mean? 6, 7, 8. What's one less than 6? It's 5. So I'm going to put the 5 in there. So again, we're going to do our second VAR's binom. So I'm going to just write out binom. And this time it's going to be the CDF. CDF, 8, 0.55, 5. Okay, I want to make sure you understand it's 5. More than 5 means 6, 7, 8. What's 1 less than 6? 5. And I just did that, didn't I? And I got 0.78. 0.78. But that's not what they're looking for. You see, this right here, this CDF gave me 0, gave me the binomial for when x is 0, when it's 1, when it's 2, when it's 3, when it's 4, and when it's 5. And all they did was add all these together. That's what it did. They added them all together. But they didn't ask for 5 or below. They said more than 5, which means it's really looking for the complement. So at the end, I always got to do 1 minus 0.78, which means it's approximately 0.22. Am I doing the right problem? Yes, I am. Okay, 0.22. Good. We gotta get comfortable with more than, less than, at least, and at most. Alright, part C. It says at most 5. So x in this case is going to be at most 5. Now when I say at most 5, I'm including 0, 1, 2, 3, 4, 5. So it wants all of those below 5, including 5. Which means I'm just going to do my CDF and I'm going to input 5 in for x. Okay, so I'm going to do the same thing. So now I have my binom, CDF, and it's going to be 8, 0.55, 5 once again, and that's approximately 0.78. And I leave my answer alone. I do not subtract it from 1 because I gave it exactly what it asked for. In part B, when I use the calculator, remember it's cumulative. It's going to start at 0 and go up to that number. So I started at 0 and I went up to 5. But it didn't want that. It wanted 6, 7, and 8. So it's the complement, and I have to subtract it from 1. Alright, so that's question number 21. Let's move ahead to number 25. And it says 28% of college students say they use credit cards because of the reward programs. Oh, that sucks. You randomly select 10 college students and ask them to name the reasons they use credit cards. Find the probability that the number of college students who say they use credit cards because of the rewards program is exactly 2, more than 2, and then we're going to skip part C. Do not do part C. It will not be given to you on your midterm or your final, and it should not be in your homework, on my math lab, or anything like that. We skip part C. We don't even cover it. Alright, so let's just focus on A and B. So let me write out my information again. My N, what's my fixed number of trials? How many college students did we talk to? 10 of them. The probability of success, the probability that one of them says they use the credit cards for the rewards program is 28%, so 0.28. And again, for fun, let's find the Q. It's 1 minus 0.28, which is 0.72. And then, of course, part A. Part A says exactly 2. So x is going to be 2. We love when it says exactly 2, because that's just my binom, PDF, and I'm inputting 10, 0.28, 2. And when you do that, that should give you approximately, one second, 10, oops, 10, 0.28, 2. And I'll give you approximately 0.255. 0.255. Good. And then part B says more than 2. So in this case, x is going to be more than 2. So let's write it out. More than 2 does not include 2. It includes 3, 4, 5, 6, 7, 8, 9, 10. In my calculator, it's going to be the cumulative, which means it starts at 0 and it's going to go up to it. Therefore, what is 1 less than 3? It is 2. So in your calculator, you're going to input that for your x. Remember, you're going to do the opposite if it says more than. So now I'm going to do my binom C, D, F, and it's going to be 10, comma, 0.28, comma, 2. And let's see what happens. Comma 0.28, comma 2. We get approximately 0.438. Approximately 0.438. But remember, this right here gave me 0, 1, and 2. That's not what I was looking for. I was looking for these guys, which means I have to do the complement. So it's 1 minus 0.438. And that is 0.562. 0.562. So the answer is 0.562. And the answer for A is 0.255. The most important things to remember with this chapter is first, you got to really know how to work your calculator. There's more steps involved. So at least, at most, more than, less than. Okay, you're going to use the complements on at least as well as more than. But I say write them out. Write them out so you'll actually understand what they're looking for. More than 2 is not the same as at least 2. If it said at least 2, I would be including the 2. So for example, let's say I said at least 2. That would be 2 or more. If I said more than 2, that would actually be 3 or more. Remember, the binomial, my x's are always going to be whole numbers. There's no decimals here. You're going to want to use the complement for these. I'm going to run out of room? Yes. Use the complement. And then for things that say at most and less than, you can just use your calculator like you normally would, and that it'll give you the answer. It gives you the correct answer. Your calculator will give you the correct answer. You do not need to do anything else to it. And if I were to say at most 2, I'm saying 2 or less. If I would say less than 2, then I'm really saying 1 or less. Okay, let me know if you have any questions.